Welcome to This Explainer. Today, we're going to be doing something really fascinating. We're taking the invisible and, frankly, super often misunderstood experiences of ADHD, and we are going to translate them into a systems engineering metaphor. So if you've ever struggled to explain how an ADHD mind actually works, or hey, maybe you're just trying to figure it out for yourself, you are absolutely in the right place. We're going to look at the brain through the lens of computers, processes, memory, and scheduling. Let's get into it.
Okay, let's kick things off by crushing a massive myth right out of the gate. Is the ADHD mind just a defective machine? Like a broken computer? No way, not even close. Instead, I want you to think of it as a ridiculously powerful computer that just happens to run on a non-standard resource management system. Sure, it behaves a bit differently from what traditional schools or typical 9-to-5 workplaces expect, but as we're going to see, different definitely does not mean broken. To understand how this unique architecture actually hums along, here's our roadmap. We'll start with a different operating system, then dive into the hardware, your CPU, GPU, and RAM. After that, we'll look at schedulers and event loops, move into overload and thermal throttling, and finally wrap up with building a distributed system.
All right, Section 1, a different operating system. Not a deficit, but a difference.
This quote pretty much hits the nail on the head. The crucial takeaway here is that someone with ADHD might have an incredibly deep understanding of a subject and completely genuine intentions, like they know exactly what they want to do. The problem isn't that they don't care. The real issue is that their operating system just struggles to load the correct task at the exact correct time. The attention module itself isn't missing. It's just that the way attention gets allocated, activated, and prioritized is kind of inconsistent.
Moving on to Section 2, let's look at the hardware. CPU, GPU, RAM. This is all about separating sheer capability from execution.
Think of the mind like a full-blown gaming rig. Your CPU handles the deliberate, conscious reasoning, right? Solving known problems, following step-by-step instructions. Then you've got your GPU, which is your rapid pattern processor. It's handling nonlinear creative thought, basically generating 100 possibilities all at once. And then there's your RAM. This is your working memory, holding on to whatever instructions you're actively using right now. Now, a person might have an absolute beast of a CPU for logic and a lightning-fast GPU for creative problem-solving, but if their RAM is limited, well, they're going to struggle to hold multiple simple instructions in their head at the same time. You know that feeling where you walk upstairs to grab a charger, turn off a fan, and get a cup of water, but by the time you hit the top step, the instructions have just fallen completely out of RAM? Yep, one process just overwrote the other.
This hardware mismatch perfectly explains some behaviors that get totally misinterpreted in everyday life. For instance, if you've ever wondered why someone with ADHD might suddenly interrupt you mid-sentence, let's look at the mechanical cause for that.
From the outside looking in, an interruption seems impatient, maybe even a little rude. But internally, it is a literal RAM overload. The person is holding on to a thought they really want to share with you, but to wait politely, they have to keep that thought active in their working memory while simultaneously processing the brand new information you're saying. When that limited RAM hits maximum capacity, they feel this intense mechanical urgency to just blurt it out. It's an emergency data dump to transmit the information before an incoming process completely overwrites it.
Okay, Section 3, schedulers and event loops. We've talked hardware, let's talk about the software of task management.
Picture this incredibly common, everyday human scenario. You put the kettle on the stove for some tea, you walk away to do something else for just a second, and then you completely forget about it until you smell something burning. Why does that actually happen? In the programming world, we'd call this an event loop failure. The mental program was actually perfectly clear. Start the tea, go do a quick task, return to the kitchen. The first action fired, and the future action was queued up. But because some other highly engaging process hijacked their awareness in the meantime, that internal reminder, the callback, just never successfully resurfaced. The tea wasn't forgotten because they don't care about burning the house down. It was forgotten because that pending intention just completely failed to regain execution priority in their brain software.
And this table right here, this is a real game changer. It brilliantly shows how priority queues differ. In a conventional system, importance is king, number one priority. But the ADHD priority system, it doesn't really recognize important. It requires immediate urgency, a strong personal interest, novelty, or intense emotional stakes to allocate resources. This is exactly why knowing something is abstractly important does absolutely nothing to trigger action. A super important task due in 3 weeks will just sit dormant in the queue, while some novel, highly interesting random side project captures 100% of the system's resources right now.
Since abstract importance doesn't turn the system on, a person unconsciously learns to rely on this brutal timeline. A task sits totally dormant for weeks. Then, the night before the deadline, boom, crisis mode. The consequence becomes immediate. The adrenaline hits the system, and it is forced into a highly focused emergency state. The task miraculously gets done, sure, but the aftermath is severe burnout. The brain learns that emergency mode gets results, but relying on this over and over just damages the machine over time.
Which leads us perfectly into Section 4, overload and thermal throttling. What happens when the system just completely freezes?
Let's talk about the hidden cost of context switching. In a neurotypical system, minor interruptions are easily filtered out. But in an ADHD system, an incoming thought or a random external noise gets immediate VIP access. And every single switch has a massive hidden cost. To answer a quick 30-second question from a coworker, the brain has to hit pause on the current process, save its state, load up the rules for the interruption, and then exhaustingly reconstruct the entire original goal to get back to work. That internal context reload drains the battery fast. This is exactly why a tiny little interruption can completely nuke an entire afternoon of productivity.
And it isn't just tasks that cause this overload, it's emotions too. Think of emotional regulation as the brain's cooling fans. When a small criticism hits, the emotional processor generates a really strong signal. In an ADHD system, this emotion often gets granted full administrator privileges. It just takes over everything. The whole system overheats, working memory drops to near zero, and the CPU starts reasoning entirely from inside that hot emotional state. And it takes a really long time for the cooling fans to finally catch up and bring the temperature back down, even long after the actual argument or event is over.
So how do we fix it? That brings us to our final section, Section 5, building a distributed system, debugging instead of shaming.
I love this concept. After years of forgetting things, missing deadlines, or being told you're lazy, it's super common to develop this aggressive internal error reporting system. You start telling yourself, I always ruin everything, or I'm just fundamentally broken. But here's the thing. Telling yourself the whole machine is defective gives you absolutely zero actionable data. Shame is a terrible debugger. It doesn't tell you what line of code actually failed.
A useful debugger identifies the exact failure condition, so we have to relabel the friction. Instead of calling yourself lazy, a moral judgment, recognize mechanically that task activation failed. Instead of labeling yourself careless, realize an event loop was missed. When we swap out those damaging moral judgments for mechanical systems interpretations, we replace useless, heavy guilt with a really mature, actionable form of accountability. It flips the script from, why am I such a failure, to, okay, at what exact stage did execution stop?
Once you identify that mechanical failure, you can start building an external operating layer. Real-world servers depend on external databases and load balancers all the time, right? Well, so should you. Using external tools isn't cheating, it is brilliant systems engineering. You build external RAM by writing your thoughts down the millisecond you have them. You build an external event loop using timers to force transitions. You treat your environment as an external cache by keeping important things physically visible on your desk. And you set up external monitoring through checklists, working alongside a friend, or using AI assistants. You are intentionally distributing the cognitive load out into your environment so your brain doesn't have to desperately juggle it all.
Ultimately, the goal here isn't to force your brain to magically behave like a completely different, conventional operating system. It's about designing your life around the system you actually have. By treating this not as a moral failing, but as a fascinating design challenge, we can ask this incredibly empowering question. How should information move through your complete, distributed system so that the important stuff happens reliably? When you finally stop blaming the machine, you can start designing the architecture that lets it truly perform. Thanks so much for joining me on this explainer, and I will leave you with that thought. How can you redesign your own system today?